Good morning, good afternoon, good evening. Well, I'm going to start over. My, okay, I think my head's cut off, isn't it?
No, no, no. We see you just fine.
Okay. Good morning, good afternoon, good evening. Welcome to our fifth in a series of webinar, our closing webinar actually, on mapping the terrain, navigating the supply chain tech landscape for tactical and strategic advantage, which features our partners from SCMBLOX and the Supply Chain Risk Management Consortium. Dr. Chris White, founder of scmBLOX, founded in 2023, and PMBLOX, founded in 2015, based out of the great state of Dallas, Texas.
Big D, big D.
Big D, Big D. All right. And we have Greg Schlegel, founder, CEO of the Supply Chain Risk Management Consortium, founded back in 2011. And now he's in Lewis, Delaware.
Woohoo!
Hey, all right. And I'm Jim de Vries. I'm founder and managing partner, master integrator of over 80 partners. Of course, Greg and Chris being the primary partners, right? At
Yes,
least today for the next hour.
exactly. Yeah.
I was founded back in 2016, and I'm in Bethlehem, Pennsylvania. So again, welcome everyone. We appreciate you taking the time. This is the fifth in the series of webinars. We started off in structural modeling, the impact of supply chain policy management. We went into the physics of supply chains, then into redesigning the supply chain and modeling strategic implications of the tariffs, onshoring and restructuring. Certainly one of our most popular uh, webinars. Then we went into BCP, planning on steroids. Basically, how do you use structural modeling to help you do planning? And now we're looking at it for mapping the terrain, navigating the supply chain, tech landscape for technical, tactical, and strategic advantage. Again, we look forward to a good webinar here too. Please do enter your comments into the chat. Join the poll EV that's in the chat. When we get to it, right now there's a polling in there for where you're coming from. So let's get started on the deliverables. The deliverables started with learning how to map the supply chain technology ecosystem for clarity and prioritization. That's one thing we're going to get out of this, and distinguish tactical tools from short-term fixes, efficiency from strategic enablers, resilience, and advantage. We'll explore how AI, blockchain, and digital twins fit into the different time horizons of supply chain design. And then we'll gain some insight into the integration strategies that prevent tool fragmentation and maximize ROI, and share some playbooks of case studies to guide tech options across strategic, tactical, and operational horizons. And in a nutshell, this is a wrap up of our 5 webinars and giving you an idea of when to use what, when, and how. And that's going to be the trick here today is when to use what type of tool for what type of problem, and we'll try our best to give you insights on that. With that, I'll turn it over to Greg for his introduction of the supply chain risk management
You bet.
consortium.
Thanks a lot, Jim. Great to be here with you guys. Talk about our passion, who we are and what we do. We're 33 companies at the moment, about 1,700 risk pros around the world. We operate in 23 countries. We've been in the risk biz for about 15 years now, as Jim mentioned. What do? We identify, we assess, we mitigate, and we manage supply chain risks. How do we do that? With 3 pillars. You can see them on the right: education, consulting, and software as a service tools. On the left, we have tools and techniques. We have 2 online education courses. They're self-paced. You receive a certificate. One is geared towards manufacturers. The other is geared towards logistics and healthcare. we have a supply chain management online readiness assessment. It is free. You can get in there and assess your supply chain process maturity levels using the tool. We also have another prescriptive online assessment tool, which is geared mainly around risk and resiliency. We have a free tool out there at the moment on our website to give you a sense of where you are positioned relative to our risk maturity model. And then we can also enlighten you as to what your company's risk appetite is, your culture, and produce action plans using AI ML algorithms. But we do have a free opportunity on the website. You can take a look. We coach and we consult, and we have platform solutions geared towards risk and resiliency to do the heavy lifting. And with that, I'll turn it over to Chris.
Hey, thanks, Greg. Yeah, y'all may have seen SCmBLOX was one of the companies, the software companies that was mentioned on that previous slide. But SCmBLOX, Supply Chain Management Blocks, was developed through the military SBIR program. If you're familiar with that, primarily DARPA, the Air Force, and Army. SCmBLOX is used to take a long-term strategic view of supply chains as a system, and that's what's important, is that individual companies by themselves have limited impact on the overall supply chain. And so we look at the overall supply chain. We also have PMBLOX, project management blocks, that was also done through the DoD SBIR program, as Jim had said back in 2015. But the key here is a lot of the tools, when you see blocks, that means it's agentic AI. It's an agent-based simulation. Blocks are agents, and so a lot of the tools that we develop are what we would now call agentic AI. We used to just call them agent-based, but it's agents that have their own policies and run, and you see how them within the construct of a system act, react, and respond. So thank you. I'll turn it back over to you, Jim.
Thanks, Chris. And just a little background on Enhance International Group. We're a group of over 80 partners around the world, and we work to drive people, process, data, technology improvements, best-in-class consultant companies, and technology providers in the industry. This is our bicycle slide, and we cover from strategy to execution through tactics. And today, of course, we're focusing on supply chain risk and resiliency. And so with that, I'm just going to move on to the agenda today. So today's agenda is mapping the supply chain tech landscape, understanding the categories, overlaps, and gaps. Then we'll get into tactical versus strategic advantage and developing short-term fixes from long-term enablers. Then we'll get into STO, we call strategic tactical operation horizons, how they all fit together, applying tools across these levels. And then we'll get into technology in action, the case studies on AI, blockchain, and digital twins. And then Chris will get into some integration strategies of building coherence across multiple platforms. And then we'll get into the playbooks for resilience. So with that, I'm going to just turn this over to Greg on models. Greg.
You bet. Thanks a lot, Jim. We thought we'd start here, real straight away. What is a model? All right. And we took a quote from George Box. All models are wrong, but some are useful. Who is George Box? He's a co-author of the Box-Jenkins model and many, many other statistical models. All right. So we wanted to start here and then give you a sense of a model is a physical, virtual, or mathematical representation of something in the real world. All right. True. All models are simplifications. They're not the real thing, but they're attempting to replicate what's going on out there. All models are designed for a purpose and to address a specific range of issues. Got to remember that. And the better question, at least from George, is how wrong can a model be to still remain useful? Well, I'll answer that question. As a trained operations research modeler, all right, I've utilized many of his approaches during my supply chain career. And one of the mantras we always had as modelers was a good model is directionally correct versus ridiculously wrong. That's when you know you got something. So with that little premise, I'll turn it over to Jim.
It's great to start off with George Box. Thanks, Greg. Great story there. So we're all modelers, and Chris, Greg, and I over the years. And I think what now everybody's talking about models, the digital twin. And what is a digital twin? According to national academies, I mean, there's a lot of debate on this, but this is one of the folks that wants to define this. A digital twin is a set of virtual information constructs that mimics the structure, context, and behavior of a natural, engineered, or social system, or an ecosystem, or system of systems, and informs decisions that realize value. So what are some of the key words out of here? It's a virtual, and it mimics, and it informs decisions. So like George said, and what Greg just said, if you don't have an informed decision that gets you directionally correct or versus ridiculously wrong, then that digital twin is not doing you justice. And there's different digital twins and different horizons that serve different purposes. And so what we often see is the wrong model being used for the wrong type of problem set. So that's what we're going to get into throughout this webinar. So what we want to ask you is, are you using or applying digital twins in your workplace? And where are you applying them? So some are applying them in planning, inventory there. Thank you. Inventory. So we'll warehouse. That's great. Keep them popping. Planning. That's fantastic. Inventory. That's a common one. Yeah. So we'll keep having this pop, or I'll turn it over to Chris. What are you seeing?
Yeah, it's very interesting the whole concept of digital twins and how they're getting used and their definitions of them. And I'm really looking forward to getting into some of the later slides where we lay out. You already sort of talked about, Jim, that there are different tools for different types of problems. George Box has the comments that Greg was talking about, where some models are wrong, all are useful, and they're designed for a purpose. And so what we want to do is understand, well, what different technologies have different purposes. And so right now, a lot is being used in what I'll call the short-term operational space. You see answers like inventory, warehouse, ordering. So a lot of these are rather short term. And I think this will be interesting for the participants to see that there's this much wider range of digital twin technologies out there.
Thanks. Thanks, Chris. Greg, any comments?
Just from our risk perspective, we see a lot of clients and other folks leveraging digital twins to do risk scenario planning. What ifs? All right. What if we lose a supplier? What if we lose a customer? What does that do to my bottom line? And then also append a risk to that to make an informed decision. That's what we're seeing, folks leveraging digital twins in their supply chain.
Yes, and I think we've all done models since we did them in Excel, or even in BASIC. Modeling has been around for years. And as Chris has often said, even in Excel, you're building a model of something and you're trying to represent something. So there's no wrong answer here. It's just, what are you trying to do? And is it getting you closer to your destination in helping you get better every day? So with that, we'll move on to the next section of the tactical versus strategic advantage and developing separate short-term fixes from long-term enablers. Greg?
You bet. Thanks, Jim. We'll talk a little bit about get you grounded on 3 time horizons for resilience. These are the 3 time horizons that we in supply chain get certified on. All right. And we live, if you're in supply chain, we live these time horizons every single day. First and foremost on the left, strategic long-term resilience timeline. What do we mean by that? Well, that's looking out 1 to 3 years in the future. Some of the current risks, you can see them, are pretty strategic, perhaps critical mineral shortages, rare earth elements, geopolitical fragmentation, which we're all living with today. What are some remedies? Well, you develop a digital twin that we talked about so far. You go through some stress testing to try to see how your supply chain will react to certain large scale strategic risks. An illustration, maybe you develop a digital twin to take a look at reshoring manufacturing, like we have talked about in the past webinars. The second element or horizon is tactical. That's mid-range trade-offs, and that revolves normally around anywhere from 3 to 12 months. Mid-range approach, looking forward. Current risks, okay, you got the bullwhip effect from demand supply imbalances. You can handle it handles labor shortages in terms of your capacity. What are some remedies? Maybe you talk about and think about dual sourcing, maybe some nearshoring, maybe holding more dynamic safety stock to handle the midterm disruptions. Some of the illustrations could be shifting some of your facilities and suppliers closer to home. The last horizon is short term. That's kind of immediate survival. We think of it as it's the next 90 days. Some current risks, sure. Extreme weather is going to perhaps disrupt your production plan. Cyber attacks, they're always out there. Some remedies, maybe expedite shipments, in a pinch. Buffer inventory, as we talked about, and an illustration might be you have to expedite air freight and so forth because of a short-term disruption. So we wanted to give you a sense of the STO, strategic, tactical, and operational horizons that we all live with in supply chain. With that, I'll turn it back to Jim.
And we'll get to the next section here on those frameworks, the STO framework revisited, applying the tools. And I'll put it right back to Greg. Greg?
Yeah. I'm back like a bad penny. All right. But we thought we'd, again, move forward with a quick couple of threads on simulation and observations associated with these horizons called strategic, tactical, and operational, just to get you grounded. On the top sphere, strategic aspects. All right. They're at the top. There's something out there called strategic risk paradox. What the heck does that mean? Well, what we've found with our risk friends over the years is most chief risk officers and other execs spend very little time on strategic risks. Why? Because they have low probability of occurrence. And so it's not immediate. So we don't get engaged with them, yet they are the highest negative impact over the last 15 years. On the bottom left, STO perspective. Let's talk about strategic, tactical, and operational. What we do in the consortium is essentially we have an online free assessment tool with 13 tenants. You can go in and assess your supply chain process maturity in those 3 areas, strategic, tactical, and operational. It's free. Over on the right-hand side, the third sphere, simulation, structured simulation. We're going to talk about that all day today, all right, and talk about risks and issues. Structural simulation, and Chris will enlighten everyone, really doesn't require a host of data. It's more relationship oriented than data oriented, and that's why we think it's very effective. So with that, I'll turn it back to Jim.
Oh, Greg, we got a question here before we leave the slide.
Sure.
Are there strategic risks that are high probability?
Yeah, and
Good.
Jim,
Go
I
ahead,
jumped
Jim.
on that. I saw Mark put that question out there, and I said, thanks to COVID, pre-COVID, things were fairly stable, and a typical approach was to say, well, what's a severity and what's an occurrence of a risk? And it
Yep.
may be very, very severe, but the occurrence is very low, so we may not give it much attention for one that has a low severity, but is hitting us all the time, a death by 1,000 cuts kind of thing.
Mm-hmm.
But thanks to COVID, we've seen the fragility of supply chains. We've seen the interconnectedness of global supply chains, and no company is an island. And so now we're seeing what used to be high impact risks that don't happen often are happening more often. So they theoretically are bubbling to the top of the list more now than
Yep.
they were before.
Yeah, I'll jump on. I'll add a few more threads to really try to straight away answer Mark's question, and that is yes, weather. Weather is a strategic risk, and it used, as Chris said, it used to be very infrequent when you profile the different frequency of occurrence of risk categories. But with the global climate changing, weather risks are strategic because they can truly negatively impact your supply chain. They are happening more frequently, so they have a higher frequency of occurrence around the globe and high impact. Hopefully, I answered your question, Mark.
Great. With that, we'll just move on to data and digital twins. So we have connected data with more data and disconnected data with less data. So if you're connected, you have highly connected digital twins operate in near real time. So they continuously synchronize with physical systems. So that's like updating every second or 10 seconds or let's say less than a minute, those systems updating and re-engaging. And we do have one of our partners, Creatisoft, that focuses on that, and they require large volumes of accurate, timely data. So for him, he has to clean the data, make sure the data is very clean, the sensor feeds, the transactional data is meaningful. And if the data is not there, then maybe add some sensors to make it more meaningful. So doing real-time digital twins is an art in itself, so to speak, a class in itself. Then you have disconnected data where you have less data on the other end, where the twins rely on static or periodic data updates, and you have more assumptions, but you're looking at aggregate level, some simplified assumptions and historical data, and the models are effective for strategic planning and scenario analysis and long-term decisions, and where speed and granularity is less critical. So that's where we're getting into structural modeling. And so it's not one is better than another. It's using the right tool in the right place, which we'll get into a lot more over these next coming slides. So with that, I'll turn it over to Chris.
Hey, thanks, Jim. So what I want to introduce to everyone is this landscape of digital twins within the supply chain domain. It helps to have, we have maps with landscapes so we can tell where we are and what's coming up and what to watch out for. And same thing here. I like to lay out the supply chain domain with this diagram over the next couple of slides here, where we will look at how where things fit. And so let me just kind of lay this out. You got two axes. At the top, you've got a time horizon, and we're going to see things like short, short, medium, long, kind of like the STO that Greg was talking about. And on the left here, we've got depth in the supply chain. It starts with a customer. So whoever I am, I have a customer, and maybe I even have distribution centers. But then there's me, my company, and I've got my tier ones, and maybe there's some warehousing in between me and my tier ones. But then there's the rest of the supply chains, my tiers, 2 through N down to raw materials. And so you kind of see that on the left, the depth of the supply chain. And where you might be in that supply chain. And then you've got time horizon, like I said, on the top. So you got days, weeks, quarters, years, kind of short to long. And the first thing I'd like to point out is what Jim was talking about with data connections. What we often find in this space is that the more you are in this upper left part of this landscape where you're looking at your company, things on the order of days, maybe weeks. You've got a lot more real time, maybe directly connected or near real time, quick updates and everything, much more connected with actual data that needs to happen. But as you get into that lower right, the more strategic, deeper supply chain, larger view of the supply chain, it's a lot more disconnected. You don't have data with a lot of these situations. And so, there you have whatever, as Jim said, historical data, whatever data might be available, but you're not connected anymore. And it's often this one-off model that's running, taking a look at some what-if scenario, for example. So I wanted you to see that data on this landscape. I also want to introduce this concept of different classes of models, and this will get back to the landscape eventually. And I want you to move from the bottom to the top, low fidelity or realism to high fidelity or realism. So at the lowest, you've got ad hoc or basically, free form models. There's nothing. There's inconsistent methodology. The quality of any model can vary greatly, and it depends on who's actually doing the model, developing it, or whatever. Depends on how good it is. Then we get into this level, this analytical or mathematical level where we can directly calculate something. We often have equations, there are trends or correlations, and we can calculate. So for time, think net present value for, time t equals 10, we can actually put t equals 10 into the calculation and calculate that. If I've got a demand forecast that says, well, in 6 months, I can put 6 months in there and it shows what happens, what that data is. So there's a big focus on data and statistics that I need to build those models. At the top, the most realistic are operational or activity-based. Those capture the cause and effect relationships that exist in the system. And so they actually execute and try to mimic the activities, and projections, future projections are generated from walking through these activities. So there's more of a focus on the structure and the connections that are in that system than the data about that system. Now, you've heard us talk, there's another way to look at this. You've heard us us use the term structural modeling before and statistical modeling. Well, this is where these fall on this chart. Operational models that focus on the interconnections, the cause and effect linkages, that is structural modeling. And this analytical is the statistical modeling where we need data. The models themselves are built on data. If you don't have the data, you don't have a model. And so that's very important to know. And in fact, that extends to if you're using AI, a lot of the AI methods are based right here in this analytical or mathematical or statistical domain because they are data driven, and I need data to build those models and train those models. So that's where AI actually falls. Now, we can look within these. I've kind of broken out general types of technology. So again, we've got the ad hoc, the analytical, and the operational on the left. And this is still sort of building up bottom to top in terms of realism. So at the bottom, ad hoc, best guess, right? I mean, there's no structure to that. It's kind of an analogous effort. Well, this one feels about 30% more complicated. So whatever we did last time, let's multiply it by an additional 30%. And that's our answer. You hear back of the napkin kind of stuff. That all falls there. Then you get into spreadsheets. We talked about spreadsheets can be digital twins. They are models. You're trying your best to mimic what's happening, but they are very limited in their capability. It also depends on who's doing the model. You can, one person that has limited knowledge of equations within a spreadsheet will build a much simpler model than someone who knows pivot tables and VLOOKUPs and all that kind of stuff. This is very common. Spreadsheets are available, and so most people know this. You start moving into analytical models, and you have parametric models that are generally these curve fitting models. So when you think demand forecasting or something, I've got history of this is what's happened over the past. I'm going to use that to project into the future. And so very, very dependent on data and clean data for getting some accurate estimates or projections. Then you get into the world of network models, where I'm looking at network nodes and pathways and things like that, flows through nodes. Linear programming would fall within this domain. Non-parametric models fall within this domain. but they are looking at things as a network of nodes, and what does that mean? Now we get into more of this operational simulation. You've got discrete event simulations that are great at capturing operational activities, and they're very detailed though. So even though this is operational in its approach, it still requires a lot of data to drive it to understand. And then at the top, you've got agent-based and system dynamics or continuous modeling and simulation that now really look at the structure, the policies, the way, the behaviors that an entity may have within the system or the activities that you're looking at. And it's not dependent on data. Those relationships hold regardless of the data. Data is used to calibrate the model and make it better. But what's key here is that it incorporates feedback. And so you can see how agents or entities within a model adapt, recover, react over time, and how everyone else then adapts and reacts based on that. So just wanted you to kind of see that. And with everything, there's good and bad, right? So with each of these tools, there are certain benefits. You know, you're down at the spreadsheet, the ad hoc end, and there's little training required. So that's a benefit. We can get something fast. It's quick and easy to understand. I don't need a lot of technical knowledge. But then the disadvantages are they really aren't extensible. They apply to some unique problem. It depends on who's building it, all that. Now we get into more of the analytical or the mathematical models, which get are still accepted and used a lot. So that's one of the benefits. And even with network models, you begin to understand relationships, but it's more just I'm connected and I don't know what the nature of that connection is necessarily. But you're very dependent on data. It assumes if you're dependent on historical data, then I can only model things that have happened in the past. So I am assuming that the future is going to be like the past, which often isn't the case. So they have limitations there. And then as you start moving up, more expertise is required. So then you get into these operational models, and they're great at capturing connections, cause and effect, and feedback loops. However, again, every tool has its disadvantages, or every technology. So with discrete event, you lack some of that feedback that is in the agent base and the system dynamics. However, Jim pointed out earlier, that's an aggregate approach. So I can't track one thing through that model. I'm looking at things and flows in aggregate. So again, you got your benefits and disadvantages of each one. So, Jim, I'll let you talk a little bit about some of that.
Well, I think we covered this before, but that when you're looking at your problem that you're looking to solve, I think one thing to always look at is what data do I have and what data do I need to be able to direct the answer that I'm looking for. So, do I have the data? So often we don't have the data that we need to make the decision that we're looking to make. And at what time frame are we making that decision? So what we've worked on over the years and what you see a lot of in the IoT is trying to bring in more data to get connected. And large language model is a very good example of that, of unstructured data, where you have connected data, it's unstructured data, but we're using that to help build up the typical data that ERPs and MRPs and NMNLPs, so to speak, are managing in your system. So one thing to think about is that ERPs are built to collect financial data and use in a transactional environment, but they're not really transactionally based. So that's one of our challenges on the transactional side. And then on the disconnected side, what the structural modeling is, what are those big animal types of problems that you have that don't need a ton of data? Because if you take all the time to get that data, you're not, by the time you get the data, it's already passed. So can you make some high level assumptions on the data and get yourself directionally correct? So it's a balancing act. So you can look at this connected, disconnected as a balancing act throughout your search for the digital twin to suit your needs. So with that, I'll turn it over to Chris.
Yeah, I'll take back over. So I want to remind y'all of this slide just based on that discussion with Jim of now in this landscape that in that upper left is where you have more connections with data. And this is not good or bad. Like Jim said, there's no wrong answer. Just it's the nature of the beast is when you're in that upper left, you want to be more connected. You need more real-time data because you're making quick decisions on short periods of time. The longer down in that lower right, the longer, the bigger picture you are, it's more of a system view and you're not quite, you can be more disconnected from actual data to run those models. So just want to do that little reminder. And now now that we've got this landscape, I also want to tie in what Greg was talking about earlier with strategy, tactics, and operations. And this is where they kind of fall. And, this looks like it's got very clear lines, but it's sort of notional more than anything. That operational activities are these that are in that upper left. They involve me, my customers, maybe my tier ones, and it's called all right there. And I'm in the, days and weeks or something like that. Then we get into tactical, which are more like weeks and quarters, getting up to a year long or so, as Greg had pointed out. And I might get a little deeper and maybe look into a tier two or something like that in my supply chain. So maybe slightly deeper. And then strategic is that bigger picture of looking out quarters, if not years. A lot of work we did for the military was actually decades. And so much longer term, much bigger picture as things are adjusting and things move up and down the supply chain. And so you're down where you can do tier in raw materials. And so I just wanted you to see that laid out on this landscape. But what's really important is this slide right here, where what matters are the types of problems that fit in these places, because what we're going to end up doing is mapping technologies. If this is where these problems are, and then we know where technologies are, then now we can identify the best technology for each problem. So let's start with the types of problems. So in that operational upper left range, you have things like order fulfillment, distribution, production control, inventory control, tracking purchase orders. All this is very short term. And I need real-time data. I need data that tells me what's happening right now because I got to track this and all that. So that's on that upper left. More in that longer, that tactical framework, you've got SI and OP, you've got preventative maintenance, capital equipment. I'm going to get some new equipment. That's not make a decision and tomorrow it's there. This takes a while. I'm doing, if I want to optimize my network, that's something that's a little bit longer. I'm redesigning a product, that's a little bit longer. And then out in the strategic, you've got greenfield, brownfield type projects. You've got redesigns of supply chain. These take a long time. Strategic sourcing, long time. Nearshore, reshore, offshore, whatever you want to call that, that takes a long time to do. And so you're in that element of years and more longer term and deeper in the supply chain, often in the consideration. So just wanted you to see those laid out. Now I want to step back a little bit and just talk about just sort of business modeling in general and what's been happening and where those trends are. And you've got two sort of ends or two things to consider when you're talking about modeling business problems. On the left, we've got the problem or the issue that we're trying to solve. And then on the right is the representation. What model, what virtual representation will we have? And so those are two ends. Well, they require typically different kinds of expertise. I need business expertise to understand the business problem, and I might need simulation or some sort of modeling expertise to be able to represent it. And so it's kind of useful to lay these out. And traditionally, the way it's been is that there's been this gap that I don't have that capability on both sides. So as Jim was heading with the next slide there, what we've got is the traditional approach is to kind of focus on the representation. And that requires a lot of expertise, which means it's a lengthy development cycle time. It takes me a while to develop because it's all this expertise and I want to get all this in there. Well, because it takes longer, there's less confidence in those solutions because I needed that solution and now you're giving it to me 6 weeks later. And because there's less confidence, there's less action or delayed actions are taken, which leads to less ability to solve the actual problem. And so we've got this disconnect where things are, I've got a slow approach to modeling and representing the system and I'm the business person waiting for an answer, and it's delayed and it's taking a while, and so it's no longer useful by the time the model gets to me. So where we're moving is more this new approach where less expertise, modeling expertise is required. Instead, there's a focus on the business expertise. There's less coding, there's no coding type solutions. So my development times are shorter for my models, gives me higher confidence, allows me to take quicker actions, and it leads to better solutions because I'm on top of it and I'm not waiting a long time to make those. And so what we've got now is this ability for business experts to make models quickly to solve business problems. That's very important, this trend. So you hear things like no coding and all that. That's what's happening. Like when someone's even in the world of coding, someone's typing, C sharp or whatever language, it's translating into assembly language. No one works at the assembly language level, but that's where it all started, and that's what it's got to get down to. So it's that same thing. It's these different representations that make it much easier for someone to build models. So now let's look at those models over here. We talked about three classes of models. So the first one was ad hoc. And if you're going to use ad hoc, I want you to think this is sort of the only abilities of ad hoc because they're unstructured and inconsistent and they don't have much depth to them. I would, the only place they can really be used safely is things that are very quick and I need immediate answers, I need immediate calculations and answers to get to it. And so that keeps ad hoc in that upper left quadrant or, kind of this model. If we take a look at analytical, analytical can handle that and move out a little further into that more tactical space. And then last of all, if we look at operational, that can actually handle any and all of this now. And so when on this next slide, when I lay these out, I want you to understand this is moving from the upper left corner. So it's not saying that operational is only good in this bottom right or analytical is only good in this one strip. Remember, this is kind of from that upper left corner and its ability to come into the rest of that domain. And ad hoc is limited. Then you've got analytical, which gets you a little further, and operational, which kind of gets you the furthest. So here's where it all here's the punchline. Here's where it comes down to, well, so how does that impact me and my digital twin decisions? Well, if you're using spreadsheets, ERP systems, their only domain is really up here in the upper left. Those are ad hoc approaches, and by their technological nature, they are limited to just these short-term operational decisions. However, now we move into some of these other tools that are more analytical or mathematical. They get you a little further into this landscape. Network models, linear programming, large language models that Jim mentioned, AI, parametric models that are statistics based in nature. Those get you a little bit further. So my analytical models and modeling approaches or technologies get me into that space so I can start answering the questions in that space. Then last of all, you have the operational models. You've got the discrete event simulation, the agent-based, the system dynamics or continuous simulation. But discrete event bias nature and its dependency on data limits it. So it gets a little further than those other analytical approaches, but really not much further. There's limitations in terms of data and trying to track every single item moving through. And so now in that lower space, the only real possibility are agent-based and system dynamics based models. And that's what SCmBLOX is. And so we're down in this space. So SCmBLOX would not be used to understand tomorrow's inventory levels or next week or do demand forecasting. It is in that big picture space down in the lower right. But this last slide gives you a feel for the types of technologies to use for the problems in these domains. And so now you got a notion and an understanding of the right tool for the job. I think, Jim, yeah, you're the one back on.
Yeah. So now reflecting on all these areas that folks are using digital twins in inventory, warehouse, and factory layout, you can kind of map these to your previous slide, right? And what time horizons that they're able to be used. Do you want to talk about that a little bit, Chris?
Yes, and I was just answering Mark. So I'm sorry. Repeat that question, Jim. My apologies.
Yeah, we should read these out loud. We shouldn't be answering them in the
Yeah,
chat.
so Mark had asked, in the traditional approach, doesn't the time to build the model depend on how much you believe George Box? I can build a quick model that may not be very accurate, but is useful. Absolutely, it all depends. But the more you do that, the more it falls in an ad hoc category, which is the least lowest fidelity, and begins to put you in that upper left corner where I can't make a fast calculation on something that's going to be months and years out. Uh, so you begin to limit yourself, but you're absolutely right. I mean, it is possible.
Great. Do you want to comment on any of these on how they fit into?
Yeah. Okay. So now you're looking at some of the answers that people have put: inventory, warehouse, plant, factory layout. So factory layout begins to get into that more tactical range. Some of these others are in that upper left. And the reason a lot of those answers, if you'll go back to that word cloud again, a lot of those answers are, you do see scenario planning, you do see factory layout, you see some that begin to expand. But the tools that we have today are way up, are in that upper left. So we tend to want to use the tools we already have and are familiar with. And so we tend to live in that upper left world. And what we, as folks within the supply chain domain, need to begin to understand is to kind of pick our heads up and get out of that short-term myopic view of the world that's very efficiency driven and drive costs down and all that. And if we really want to talk resilience in supply chains, which is a popular subject, and as Greg talks about in supply chain risk management, we want to begin to explore that strategic end of the spectrum, the longer term, the bigger picture, the supply chain as a system, and understand the resilience of that system, of which our company is just one player in this larger system. And so this is a good diagram that just lays out that landscape and says, where am I? What problem am I trying to solve? And what's an appropriate technology? And start picking that tool or that technology for that problem. And then you've got the best solution.
Another aspect of this is the juice worth the squeeze, right?
Yeah.
I mean, you're trying to squeeze stuff out of the daily operations, but you have a strategic impairment or a tactical impairment that's preventing
Yep.
your company. So what I see repeatedly over the years is people are trying to milk that cow or squeeze that lemon
Yep.
in that upper left-hand quadrant, and they're letting the tactical and strategic decisions completely decimate their business.
Yeah,
And
absolutely.
and that's where I see, and they did not have the tools to be able to see that before.
Yeah.
So I would encourage folks to, I think we were limited at discrete event simulation. 10 years ago, all they talked about is ERP spreadsheets and discrete
Hmm.
event simulation. That was it.
Hmm.
Now there's a host of other tools out there that are available that are not requiring a PhD, three
Hmm.
PhD person to do the analysis and spend a year on your company to do that analysis. Now these analyses can be done in days
Yeah.
or
Literally.
hours
Yeah.
that used to take years to
Hmm.
do to help you with those tactical and strategic problems that have been ignored that are actually causing further problems where you sub-optimize why you're trying to optimize in that upper left-hand quadrant and you're actually sub-optimizing the overall system.
Well,
And I think that's changed in the last 3 years in this world.
absolutely. You'll notice as you get into that upper left corner, that's less and less of this. It's more and more just about me and what I'm doing in this whole system or this whole supply chain. And we know when you optimize the parts of a system, you end up sub-optimizing the overall system. But yet we tend to forget that. And like you said, these are the tools we have. So we just, you know, double down on these tools when really they're actually creating problems for us in the long term.
So with that, we'll go into the last section on the playbooks for resilience, and we'll kick it off with you, Chris.
Oh, that's right. I'm back on here. Yeah. So one thing I want to point out when we talk about digital twins and these different time horizons and everything is that you're using more digital twins than you actually may realize. You hear the term digital twin, but hopefully this has opened your perspective and understanding of what all falls in the domain of digital twin. And a lot of people tend to think digital twins are only those that are truly connected with real-time data and mimicking the real world on a real-time basis. But we've shown you that there's digital twins that are less connected and still just as valuable. So all your spreadsheets and ERP systems, those are, warehouse management. Those are all digital twins you're using. However, this is our main point here is that the effectiveness of the digital twin depends on the business problem that it's being applied to. And so we've already pointed out that the ad hoc digital twins kind of vary in effectiveness. Those are the ones you want to sort of avoid in most cases. I'm not saying they're all bad, but you have to have the right modeler, you have to have the right knowledge, all that kind of stuff for that to really work. Analytical or statistical models, AI being falling in that realm, those digital twins are great for operational and tactical issues in time frame. So anything that falls within there, those are great at. But if you're really going to expand beyond that, then you really need to look at operational or structural types of digital twins that can handle the rest of that spectrum or that landscape, the longer term, the deeper into the system is what you want to look at. And so if you're in that big picture realm, then the agent-based system dynamics digital twins are the most effective in there, which is what we're pushing, is that we need to lift our heads and do some of this long-term analysis. So this whole series has been based on doing these long-term strategic what-if analysis. And we're just saying that if you're in that realm, then agent-based or system dynamics-based tools are the most effective for doing that.
Yepper. All right. Thanks, Chris. We wanted to kind of give me a quick summary or what we call the moral of our story today. First and foremost, understand the business problem that you are facing. Remember, we all probably have heard knowing the problem is half the solution. Another one, understand the benefits of each type of digital twin. I think Chris did a great job of giving us a portfolio of benefits associated with the type of problem and the capabilities of the digital twins. Another is apply the most appropriate digital twin for the business problem. And you may have to realize that you need potentially multiple digital twins to potentially address multiple problems. So the net from our point of view is know your tool limits. So we just wanted to kind of put a bow on our discussion, and I'll move it over to Jim for a wrap up.
I want to thank everyone for the attending the webinar. Please feel free to reach out for questions on digital twins to Chris or Greg or I. We'll be more than glad to support you in your journey of using digital twins. It's going to be a journey. So I'm not going to go through the deliverables again, but if you have any questions or comments on any of these deliverables, please let us know either now or send us an email. Please do reach out. This does wrap up our webinar series, the 5th. We'll be coming up with a new webinar series over the holidays, and we'll let you know what that is starting next year. And I hate to say this, I think this is the first time I've said it, but happy holidays and happy New Year, because we will certainly be back next year with this webinar series. Thanks so much. And Chris, your closing comments?
Yeah, I really liked the moral of the story that captures it all, that you're using a lot of digital twins. Just understand which problems those are effective at. Quit trying to take a hammer, Olive Guy's a hammer and everything's a nail. Then quit using. Understand you have a more possible tools to use, and you want to use the most appropriate tool for the job. So based on the problems you're trying to solve, find a technology or a tool that uses that technology and use that to address those problems. I think the moral of the story was a great slide.
Yep.
Right.
Yep. Thanks again for your attention. Hopefully, we hit a few, you gather a few nuggets. This is a pretty complex thought process. We like structural modeling, especially as it relates to looking at long-term risks and rewards. So with that, thanks a lot for your attention.
And I want to thank everyone. Walter, please do send me an email. I'll follow up with you on your question in there, and we'll pursue that. And again, thanks everyone for joining us. This has been a fun series, and really enjoyed it. Learning all the time. That's what's the fun about this, and it's changing every day. Digital twins are changing every day, and what is great now is that there's so many more tools available. So everything that you wish for, maybe when you were a young engineer or a programmer, that it's available. So look out, see what's available out in the marketplace, and with digital twins and AI, LLMs and agentic and every other part of AI that's out there, we'll expect to see more. So very exciting times in the next decade. Who knows where we'll be? So thanks so much and enjoy your holidays.
Thanks, everybody.
Cheers.